Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming to you from the Mozaic Works studios, and today we will discuss about a very interesting topic, starting from a question from Adi. So welcome, Adi.
Hello.
Before we go into the question about architecture, what else have you been doing since we last discussed?
Well, many things. But yeah, let's say that I'm continuing to work on this team coaching, both organizational and technical some architecture as well in this yeah, that's also why I asked about this, because we have some situations in these teams where there are some there's some need of understanding more what is happening. Being a very big customer with many systems, applications, and so on, you need to understand what's going on and how they work.
Right, and you are asking about fitness functions, right?
Yes, basically, more and more, I think we're interested in everything we could do to do testing on live systems, but in production, but also on all the other systems, like on dev environments or on test environments. Especially the more you integrate environments, the more you have the need to understand if they're working well. Because downtime to such test and dev environment integrated this environment means that you lose time, you lose money. Now, of course, there's also the other approach, not to integrate environments, and this is great. I totally support that, but sometimes you still need to test at least once integrated the whole thing. So that's why I'm interested in everything that means smoke testing, both or in from 3 points of view, or four, in fact. So I mean by smoke testing here, to look at infrastructure, if things really work well, like if you still have that much memory, database space, if you still have capacity at CPU and so on, functional from some point of view to have the critical path of the system, architecturally if things are working well, and also once you have microservices to make sure they're really functioning and you don't have zombie processes. So all of these things about monitoring is really important, I think.
Right. So these are quite separate from fitness functions.
Of course, yes. But that's why I was interested in what fitness functions are as well, because they come before, right?
So
as far as I know. But you'll explain me more.
Right. So just to tell our audience, if you want to test things in production, basically what you can do is to have some automated tests that you run periodically as monitor, as a kind of monitoring approach. And then you structure these tests in a few categories. Some of them will be, as you said, smoke tests, basically figuring out that the most important features are still working. And then you might have other types of tests, for example, security tests that run from time to time that check for vulnerabilities, particularly for vulnerability, the common types of vulnerabilities, but also additional ones that you found with pen testing. And then you might also have things like performance scalability from time to time. And occasionally might be useful to run reliability tests, which are weird in the sense that you are actually simulating a disaster scenario in production, which is and trying to find out problems. And here in Romania, we had a famous case with ING Bank. They did such a disaster reliability test with simulating a fire in their data center. And it actually took everything down for, I think it was for a few hours, like 8 hours or something like that, or a full day. I don't remember
more
exactly.
More or less a full business day.
But it was, this is what's strange about reliability tests. From the point of view of the reliability test, it was successful because it found issues with reliability. But from the point of view of users, of course, not that nice. But this is why it's a bit weird. And so here what you have at the extreme is chaos engineering pioneered by Netflix, who is actually periodically, automatically turning down services, servers, areas, and everything needs to be still working correctly. So you as a user should not notice that, let's say, a full AWS area is down for Netflix. You should still get the video and whatever you're looking at. You might notice a bit of weirdness, but nothing that impedes the major functionality. And I think in addition to that, there's the principle, that goes into architecture of how is it called? So the features should still work even if the services are down, even if they don't work as nice as before, but nothing should crash, nothing should...
Resiliency, right?
Yeah. It's how is it called? Graceful degradation.
Yeah, okay.
All right. So this would be for, let's say, a very short overview of what you can do for the runtime thing. But there are things that you can do, as you mentioned before that. And so architectural fitness functions are something quite complicated in the sense that you first need to understand what evolutionary architecture is.
Okay, so already it's difficult, yeah.
Yeah. So evolutionary architecture comes from the idea that what we are having, when we are talking about architecture, we are not talking only about the technical system. We are talking about a socio-technical complex system that evolves in time. And this system can evolve in a few different directions. And I will give you some examples. So let's say you are the architect for a large system, and you decide that you'll be splitting things into layers or tiers, right? Now, let's take the typical one. Okay, we have the 3-tier architecture. We have the UI, business, and data. And you decide as a rule that UI should not call the data layer directly or the data tier directly, because you know that will create coupling between UI and data, and that will lead to your architecture getting stuck when you need to add more features, right? Well, if you're just doing this and you're saying, okay, this is the architecture diagram, this is how the rules that we are using for writing the code, you can bet that at some point some program will call from UI directly the data.
Of course.
I mean, obviously, it's human nature. And we used to say that it's because programmers are bad or unattentive, but sometimes it's the fastest way of solving something. You are in a crunch. You need to do that. You forget about, all those rules. You just need to make things work. Also, sometimes it looks, from a programmer perspective, it looks as if it doesn't make any sense, to be honest. Because if your business layer is only translating things back and forth and is not doing anything with what is getting, it just looks like extra work. And programmers and humans in general want to remove extra work.
It's the minimal resistance, right? It's the minimal path of resistance.
Right. And now, if you are a good architect, you'll be involved in the development. You might notice this. But it's also something that's very difficult to notice, right? Because you'll not review all the code that programmers are writing. You will review some of it. You will not review, everything about architecture. So then this is an example of the architecture evolving in a direction that's not useful. So it decreases its fitness, basically.
Okay.
Because later on, when you need to change the database, you realize, we have coupling with the UI, and now what the hell do we do? Because we need to make a lot of changes in the UI as well, right? And this is one, let's say, typical example of fitness function, and it's actually one that you can write with, you can automate with something called ArchUnit, or there's another library, I think, in .NET that does the same thing. So basically what you can do is to write some architectural tests and say, and these are tests that run on the code structure and not on the code.
Mm-hmm.
So it's a kind of analysis. It's a kind of specialized rules that you add, but that are fit only for your specific architecture. And for example, this will say no classes that reside in a package, let's say UI, should depend on classes that reside in a package, let's say data.
Mm-hmm.
And you have these tests. You run them automatically. And if a developer does this, you'll get a message from your continuous integration system saying, oops, we have a coupling.
Okay. So this is more like a contract, right? So you have the contract of how you should write things, and then you just check that whoever is writing the code respect the contract.
Exactly. Although, so a contract has different meanings. When I think about a contract, I think about at the level of a class or at the level of an API.
No, I meant more like a social contract, like like a contract you'd sign with the I don't know, with your internet provider saying you want I don't download pirated movies, and then if that happens, like if you're in France, if that happens once, they catch you, they send you a message, say, hey, you shouldn't do that. We'll send the police on you the third time.
Yeah, I mean, it's about maintaining the integrity of your architecture, more or less. So this is, let's say, a very simple example. And you can expand this example to any kind of modular architecture. So you could say things like, let's say if you have microservices, each microservice has should have a way to communicate with other microservices. And let's say you have, what you should do is to find the bounded contexts in your system.
Mm-hmm.
And inside those bounded contexts, you might say, okay, so these microservices that are inside this bounded context, they can't call directly each other because they will more likely change with each other, and because performance is important within the bounded context.
Mm-hmm.
But outside the bounded context will only converse through events or messages. And then if you try to call a microservice outside the bounded context, only you are not allowed to call it directly, but only send messages through a message queue or event bus or whatever.
Yes.
Right? So this would be a higher level architectural constraint. And of course, it's not as easy to implement as this. Because it depends a lot on how you structure your code, but it might be something based on namespaces, or it might be something, you have some additional rules that you follow.
Mm-hmm.
Keeping in mind that rules like, if there are rules that you can follow easier than others. It's easier to follow rules like all the microservices in a specific bounded context will have this namespace.
Of course.
That's quite easy, right? And everybody is used to that. But it's harder to follow the rule of do not call these other microservices directly, because you will be tempted occasionally to do that, right?
Yes, for sure.
And so you might have things like classes that have name matching. Something should only have dependent classes that have name,
Mm-hmm.
You can also check things like implementations. So if you implement a specific interface, then the class name should be a specific name, or it should only depend on other class names, and so on.
Mm-hmm.
Oh, look, there's actually a layer, even a layer definition here. So there are all kinds of checks that you can test with automated things like that. So now if we go back to fitness function, so a fitness function is used to summarize how close a given design solution is to achieving the set aims. So technically a fitness function is not a Boolean value. It would be something between 0 and 1 as a value. But of course, the simple thing is to have Boolean ones. However, you cannot have Boolean ones for other things like operational constraints.
Mm-hmm.
So, right. So for example, let's say I define a target response time for a specific function. I know I have an algorithm within my my code that will run for longer, and I just need it to run within a very specific time so that I get the performance that I need on a higher level. And then I could measure that performance occasionally and give it a score between 0 and 1 depending on where it is.
Mm-hmm.
Right. 0 if it's outside, if it's much longer than what I need, and 1 if it is very close to what I need. So that would be another example. And now I've just seen this. It's an article from ThoughtWorks called Fitness Function Driven Development, which takes this to the next level, which is fundamentally you write fitness functions.
Yeah, and then you need to write So those are the drivers of
Exactly.
everything you do.
So you write some tests and this is actually something that I've always advocated for. Like if you look here, what you'll have in terms of this is a very good diagram because it shows you what you could have in terms of fitness functions. Some fitness functions are about code quality, right? I mean, you could write things like, as we've seen, rules about naming, for example.
Yeah.
Maybe you have a few domain names that you've already defined in your domain model. You want those domain names to appear everywhere in your code. So then you can actually write that, only those substantives are accepted in a specific package, which is your domain, your core domain or something like that. So it's important to understand that these are very, very contextual. These are no rules that you write for every possible application. These are rules that you write for your application.
I'm not necessarily sure that it helps or it always helps. So to write these types of tests.
I know some of them will help, definitely.
Yes.
As you've seen, so this architectural fitness functions, this is from Technology Radar from ThoughtWorks, and it was still on trial. And I think they removed it from the current edition.
Okay.
So they seem to not be on recommended this one, but honestly, I think it would make a lot of difference if we did. One thing I'm advocating for though is to try not to implement hundreds of these, because it will become very, very annoying.
Yeah.
It's like with static analysis of code.
Yeah, you need just a few and powerful metrics.
Yeah. So ideally you would start with the most important ones. And for me, these would be things like performance, resiliency, maybe a bit on code quality, although, maybe some naming, maybe some things like that, if you have certain rules. Maybe something related to security. But then just have a few of those and add more as you notice that people are moving in the wrong direction and forcing things. So this is how I would be doing.
So where do you think it's more appropriate to use fitness functions, and where would you think they're not suited for?
Well, obviously, if you have a very simple product, you most likely don't need it. If you have a very disciplined team, people who remember the rules, who can actually, ration about the rules maybe, who don't need them to be remembered, but they just will follow them naturally, then you most likely don't need this. And this is why I'm thinking of it in terms of a system, right? Usually in an organization, you know what problems you had in the past. You know that maybe at some point somebody coupled things that shouldn't have been coupled, or wrote some code that was not as performant as it should have been, or introduced security vulnerabilities or things like that. And so I would start with the repeat offenses before I move to more detailed stuff.
I see. So it's just making sure that you don't repeat the mistakes.
Yeah, from my point of view, yes. Might also be useful for if you are moving to a completely different type of architecture, something that you've not done before. Because in that case, it's likely that everybody will go in the wrong direction. So in this case, I would probably start with more rules and then remove some when I...
Yeah, but that's difficult, right? Removing rules when you have them, I think it's a bit difficult. You need a lot of order.
Right. If you want good architecture, I mean, you do the same thing, but through the involvement of architects. Right. And by the way, some of this cannot be tested. I mean, we discussed about the nice cases when you can actually write automated tests for those. But for some of them, you cannot. So,
and which would be these cases?
Well, let's think about good design practices, like if you have low coupling, or if you have clean code, or if you have, you can measure them up to a certain point, but after that, it's just, good naming again.
Yeah, that's difficult.
You can have certain rules for naming, like, every controller to have the controller in name or something like that. Okay, that's fine. But actually this is, at least in Java, this is a problem with the way it's structured, because you can name a class. There's duplication between the annotation and the name. You'd annotate the controller as at controller, and then so it's actually a technology problem, I think. If controllers would be based on naming, then you would have to do this, because it wouldn't work. So
yeah,
and this is how it works, for example, in Grails. In Grails, it's based on names. You don't have the annotation. So there are these things that you can have that are technology specific, but then there are a lot of things that you cannot check. Or you can introduce things like you can have high coupling that is hidden between two components. Things like, I assume that component will do certain things, and so I also do some things, and then I call that component, and then, so you can do all kind of weird stuff that cannot be captured through automated analysis. So from my point of view, these are things, scalability, security, even things for compliance, having...
Yeah.
Look,
So they have the limitations.
Yeah, so GDPR compliance is something that you can test certain things. Like you could test that the logs don't contain names or email addresses or things like that, right? This is something that you can test. But it's harder to test if those are, I don't know, base64 encoded or something like that.
Yeah, that's kind of difficult.
So This is why, to me, much like unit testing, unit testing, the main goal is to filter out the most common mistakes
Mm-hmm.
and then leave. If you have your automated testing strategy correct, you will filter out a lot of the bugs, but you will still have certain bugs that are only catchable through manual inspection.
Yeah, it's true.
It's the same with this. You can have a few tests for architecture, but up to a certain point where you actually need to go and look at the code.
Mm-hmm.
But since architect time is very scarce, it's
I think so it's better to look at things that happened wrong. So in a way, you do code, you do reviews, right? But then you make sure that things that are really a no-no and that can be checked will be checked through these fitness functions.
yeah. And also the concept of fitness function does not necessarily imply that it is automatable,
Mm-hmm.
right? Because what do you want with fitness function is for the architecture to evolve in the right direction. Basically, to block it from evolving in the wrong direction, more or less. But some of it cannot be automated. So you might have some fitness functions that you write as architecture review rules, for example.
Mm-hmm.
Things that you look at when you review the architecture of as
So
it
you
is
consider
implemented.
that as a fitness function as well.
Well, yeah, because it matches the definition, right?
I see.
It's what it means is, so what do you say here? A fitness function is used to summarize how close a given design solution is to achieving the set aims.
Mm-hmm.
So if my aim, for example, is to have a changeable architecture or modular architecture or some of these characteristics, then I might have a set of criteria that I check out manually and I say, okay, we have
Mm-hmm.
10 out of 20 now.
Yeah, okay. So could this be like, let's say, a new discipline in manual testing as well?
I don't think it's fit for testers. Maybe for some testers that know architecture.
Mm-hmm.
I think it's mostly for architects and senior developers.
Mm-hmm.
And actually development teams. I mean, one thing you could do is to write those rules and to have them included in the review process for teams.
Yeah, sure. But I was wondering about the skills that you need in order to be able to test these types of fitness functions manually.
So I'm not sure how many testers will be able to say whether, it's high coupling, low coupling,
Mm-hmm.
how's the cohesion, do you have modules that are separated,
Yeah,
are the
I see.
responsibilities in the modules clear, and so on. Seems to me it's another skill, it's an architectural skill.
Mm-hmm.
And part of it would also be static analysis of code. Part of it would also be pen testing.
Mm-hmm.
Because when I'm looking at an architecture, I'm also looking at how secure it is, how is the code written in a way that avoids bugs, things like that. So this is why things like static analysis, certain rules, things like pen testing and how many security vulnerabilities do we find. These are also quite important.
Mm-hmm. Okay.
And it's something that you don't necessarily do as an architect.
Yes. Yes, for sure. Okay, so I think I understood what fitness functions are and how we could use them.
Right, and these are a few. I've just found that there are katas for fitness functions.
Mm-hmm.
This is quite interesting. So you assemble the team, figure what you're building, and then write down fitness functions. I find it to be a very advanced topic, though. So in order to understand what fitness functions you need, it's not enough to be an architect. You need to have gone through a few projects for a longer period of time.
So that you see the evolution, because you said that it's about the evolution of the system.
Yeah. Or to have a very good imagination.
Well, that's always a good idea.
But typically, I haven't seen. So whenever I discuss with, I include fitness functions in our courses on architecture, including the one for, let's say, more beginner architects, from developer to architect. But I don't stress them that much, because I understand that maybe as a developer you didn't have the vision of the whole system for a longer period of time. So you won't understand how things evolve. But you can understand things like if I write if I create coupling between modules, this is a bad thing, because you've probably done that, or a colleague has done that, or
Yeah.
And you've seen it before. So if you go to very specific examples, you can find those, but it's hard with the general idea of fitness functions, because it's really about understanding that the architecture will evolve in certain directions. And this is maybe one thing to mention here is Conway's law, right? The structure of the organization will actually be a very important factor in your architecture.
Yeah.
Right. And now imagine that you get there are some events that could happen. Let's say that you start a large product, but then part of it, you start a new company in India or in Australia or in someplace else, and you give them something to do, something to maintain, something. So suddenly you might have a completely different approach to architecture than you had until then.
Yeah, because of what you need to do, the ecosystem, how things work, the laws. I don't know. There's so many things that can happen.
And so this is one time when you probably will need to change your fitness functions. Typically, you will add more and more fitness functions as you move along, because I think the best way is to start with a small set and then adding things but if you already have a few of them, that are working correctly, but then something like this happens. Or another thing, your company buys another company or is bought by another company. Suddenly you need to change your fitness functions because you'll have additional systems that you need to interact with based on certain rules and so on. So it starts to get quite complicated in this situation. And also when you switch from an architecture to another. Many companies
because they have different views, or why?
Well, if you switch from monolith to microservices,
okay. So from one type of architecture, of course, yeah, because that's very different. It makes sense, yeah.
You probably would need to rewrite all your, well, most. Maybe the code quality rules are not changed, but the other ones.
Yeah, for sure.
Yeah. So that's fundamentally it. And I think the hardest thing is to understand this, that you're not dealing with a technical system. You're dealing with socio-technical system. Your code is influenced by the people who write it and the other way around.
Well, I think that's difficult. A difficult topic, right? And a difficult idea to grasp, maybe. Because we see, I mean, a lot of people just got to programming because they didn't want to meet with people, right? So then when you say that, it sounds really weird.
And particularly Conway's law. It's I've actually seen a tweet recently that was quite funny. That according to Conway's law, the architecture maps the communication structure in an organization. And then the second point was HR creates the communication structure in an organization, so therefore HR creates the architecture of your system. And he was saying, yeah, this explains a lot of things. I wish I could find that tweet, but it was quite funny. It's not completely correct, but there is some truth in it, right?
Yeah, because it does have an effect on the whole scheme of things, but it's not the whole thing. That's the idea.
Right. But that's the thing. There are two ways of dealing with Conway's law. You can fight against it, which tends to be very difficult. Or you can completely ignore it, which I think most people do. Or you can, the third one, is you can actually embrace it. This was there's a very interesting use case since you mentioned microservices. One of the first implementations with microservices was in the following context. They had to implement a very large application in a very short period of time. And what they said, okay, there are all these technologies now that we can use to write things like microservices. But the fundamental thing was we can parallelize the work. If we make those microservices very low coupled with each other, so we only communicate through events, then we can take advantage of Conway's law and say the people who are working on microservice X don't need to know anything about the people working on microservice Y.
Yes.
They don't need to communicate between them. They only need to know these are the events that come in, these are the events that you need to get out, and the behaviors associated with it.
The contracts.
Yeah. And then they started by doing domain modeling and for quite some time. This was a long and complicated process. It took, I think, a few weeks, if I remember correctly.
Yeah. At least 2 weeks, yes.
And then pass this to pairs of developers, and they could scale very quickly the number of people who are working on that.
Mhm.
But it's a very uncommon approach to do that. Typically, we don't know about Conway's law, and then we are very surprised when we can't collaborate well, or our architectures are not as great.
Yeah.
All right.
Okay, so this was really interesting. We should find more topics like that, I guess.
Well, yeah, and if anybody has a question, we'd be happy to answer in a lot of details. And as practical as we can.
Mm-hmm.
I hope that you can see ways of using this. So just if you look at ArchUnit, you can find some ways to enforce certain rules for your architecture. Again, my advice, just start with, 10, 20 maximum rules. And then add more when needed, but somewhere around this. Cool. Anything else you'd like to say before we end?
No, it was really interesting. That's the only thing to say.
All right. Thank you, Adi, for the prompt.
Thank you as well.
And thank you, everyone. Thank you kindly for the view. If you found this interesting, ask us other questions in the comments, and we'll be sure to take them and create some more videos like this. This is it for us for today. And until next time, remember to think, design, and work smart.